So today we have a special, different kind of video, an interview with Cole Sparks on the topic of artificial intelligence. He just happens to be my brother, but he does have a degree in machine learning. He's the chief technology officer of a CSAS company, and he was kind enough to answer some of my questions on camera regarding artificial intelligence. So without further ado, here's Cole Sparks. Cool. Well, Cole, thanks for joining. I'm going to start by just asking you off the top. Go ahead and give me what is your elevator pitch for the question, what is AI?
Uh, it's basically about achieving superintelligence, which is just like a function in programming. You take some input and return an output. When programming, that input is well defined and the output is well defined. But with superintelligence, the goal is to be able to create a software that the input is undefined and the output is undefined and can handle any possible input and produce any possible output.
What is it about right now that you think AI is such become such a hot button topic?
The explosion of it is due to the fact that we have a lot of data now and we have a lot of computing power. And that just was not true 2 decades ago. It really started to happen with Google's research in about 2015, maybe a few years before that, with the kind of implementation of what's called deep learning, which is the same idea that has been around for literally decades, since I think 50s or even before that, mathematically, and scale it up. That's what deep learning is. That's what Google did to beat, the Atari games, and they caught a lot of pop culture attention because these computers were able to learn how to play a bunch of Atari games, and that was because of deep learning, which is really just scaled up mathematical concepts that have been around forever. But now they had the computing power and the data to facilitate that. I mean, you talk about how ChatGPT is trained. Well, it's humongous amounts of data, the entire internet basically, with a even bigger amount of computing power. And it's really just a brute force strategy. And that's what you've talked about in your other videos, is that it's kind of topping out in a sense that there is kind of a limit, physical limit, that we're running into in terms of how big you can scale this same idea. It is theoretically kind of infinitely scalable, but of course you run into physical limits, which is what's happening right now.
Yeah, and you talk about that training data, which I want to come back to, but first I want to ask you, what are sort of what are in your opinion or your eyes the most promising things that are that AI has to offer right now? Like, what do you think is the most impressive aspect of it?
The most impressive thing that I've seen thus far, hands down, is Google DeepMind's research into protein folding and material science. That is the most kind of fundamentally profound application of this technology that I've seen. I think everything else has been a wash in perspective. I mean, through Google DeepMind's work, it's taken decades for humans to solve the protein folding problem, which you can research more about that. But taking the sample data that we do have that was human created through decades of research, the algorithm was able to learn a generalized model of how, to predict the shape of a protein given its genetic sequence, and predict the shape of, tens of thousands of more proteins.
What is the explain a little bit more about protein folding? What's the benefit of being able to predict that? Like, what's the application for it?
So it is a foundational part of science, of biological research, biotechnology research. And I'm definitely not a biotech expert, but to my knowledge, basically the idea is that if you can predict the shape of a protein, you can study its behaviors. And through that, you can understand how you can use proteins for various things, like, for example, disintegrating plastic or creating drugs and medicines based off of understanding its shape and therefore its behavior, because that's how they're questioned. Is you take its genetic sequence, you understand its shape, and then you understand its shape, you can kind of understand its behavior as well. So it's definitely early days for application of that research. I think somebody in that field could explain it better, and has better insight to its applications, but I know that it's just a great example of something so profound and so impactful in deep area of scientific research outside of just you know the applications that you hear about and the products that you see.
You spoke a couple times about the training material, and that's something that I've come across a few times as being a concern in terms of the kind of like potential growth. What explain a little bit to those of us who really have a elementary understanding, but I understand that it takes a tremendous amount of training material for any of these iterations to develop. What is that limitation or that wall that's fearful in terms of the amount of training data available?
So ultimately, if you look at the ARC prize challenge, which I've talked about, it talks about human priors, which is basically how when we're born we have certain kind of foundational capabilities, like ability to recognize shapes and object persistence and basic things like that that our genetic code has been developed. You can think of it like a computer program because in many ways it is the exact same thing. Our genetic code has been developed through billions of years, but also not just billion years, but billions of parallel tracks over billions of years. So just an unfathomable amount of kind of training, in a sense. What evolution has been is writing code to optimize for survival. And so you can think of a baby human as kind of um, the chat GPT, but the problem is dissimilar from the baby. uh, ChatGPT does not do any learning. If you just set it there, you can talk to it, you can read it books, but it will not get any smarter. But a child will, and that's fun. That's a fundamental difference. Is that you can spend all this training time on building up a ChatGPT, but it's just not going to learn beyond that initial training phase. Um, and they just don't have the same level of learning capability in that sense. And when you talk about data, think about the amount of data that billions of years and billions of creatures on planet Earth have consumed to evolve. You can think of every interaction with the environment and every sensory input from the environment as part of the data set. The input output. That's probably equivalent to the amount of data that's going to be needed to develop these kind of priors in a machine. The hope is that human intelligence can kind of bootstrap us and leapfrog, um, because humans have this prior intelligence that can increase the speed of evolution in a sense. We don't necessarily. The hope is that we don't have to have evolutionary scale data and compute in order to solve this problem. The hope is that we can have our intelligence and use the power of silicon based computing to leverage immense power sources such as nuclear power and the sun and things like that in order to expedite this process so we don't have to wait around billions of years.
I see so much money being invested into artificial intelligence at a really like profound rate. And I think what's the general public's understanding of it is pretty limited. And I think that um, there's sort of a benefit to that not understanding for them. But what what in your opinion is the sort of long game of these companies? Because obviously they're taking a huge risk. Do you think they see a payoff, or is it more of just like they just don't want to lose the race?
In reality, like these companies, they're massive. They're multi-trillion dollar companies. They're publicly traded. They have an obligation to grow and serve their stockholders. And when you're $4 trillion net worth, it's really hard to grow without acquiring more and more companies, without just making profound innovations. And as you pointed out before, it's getting harder and harder to innovate. So, I mean, I think it is really important that these companies do things like what Google DeepMind has been doing, with protein folding and material science. They're going to have to really start doing things that are truly profound in order to stay competitive. I think just wrapping ChatGPT in a fancy wrapper and rebranding it as their own technology, like sort of what Apple Intelligence has done. The deal that they made with OpenAI, that's not going to fly because then they will become servants of some other company and they'll no longer be king, as Apple has been for so long.
That's what I see when these sort of Google commercials where they're selling me like a rewrapped package of Chat GPT and saying this is our AI work. You know, this is our AI product. But then you're talking about protein folding and this really like why do you think that's not their selling point? Do you think people just don't understand it? Is it too complicated? Is it, I mean, why don't they come forward with some of that stuff and try to simplify it in a way people can understand?
Yeah, I mean, well, there's a couple of things. I would say these companies are so massive that they have so many things happening all at the same time. So they could be doing one thing over here and another thing over here. And the thing is, like, when you're at that scale, you're obviously going to be pushing your bread and butter. You're going to be pushing your cash cow products and services like as much as possible because those are the things that are bringing in money. Whereas the other things are R&D. They're high risk. They require a lot of capital upfront investment with no clear, to market thing. I mean, protein folding is profound, but right now it's kind of purely academic and you can talk about medicine and material science, but again, that takes years to go from research to an actual product or service that they can make money from. So it's really about hedging their bets, you know, s- just pushing the stuff that they've sold before. And they'd be stupid not to try, but given they have so much advertising money and it's silly to us because we see it so much, we can see right through it. But from their perspective, they're so massive and they're spending a lot of money on R&D. They really are trying to come up with something new that is amazing, but that's really hard to do, and they have to continue to at least stay in the green or stay out of too much debt.
I do feel like there is a marketing push right now that is cheapening artificial intelligence. It's just sort of like this one trick pony that we keep seeing. And I
Yeah.
went to an artificial intelligence summit recently where they were talking about look at all of these AI products, look at all that artificial intelligence has to offer the workplace. And all of it was pretty much just large language model. Like now it can read your emails, and that's a software, and it can do this. Now it's this can look through your notes, or this can listen to your meeting and type it out into text. And now look how they can pull from each other, and now they can summarize your emails and your meetings and all this stuff. And I'm just thinking like, this is sort of one software piecemealed out and
Yeah.
repackaged in different ways, and it's being sold as like look at all these technologies. And I'm thinking, well, this is one technology. And so it's hard as like just the general public consumer to really see like where this conversation of like AI is going to take over tomorrow. And I'm thinking, well, kind of with what? With just Chat GPT 600 times, and that's why I was kind of like, this feels almost like a marketing bubble. And that may or may not be related with what's actually happening in artificial intelligence in terms of R&D. But I would love to hear sort of, as I adjust my chair, I would love to hear sort of your perspective as you view that stuff. What do you think the relevance is of it? What do you think the importance is of it? Do you view that the similar separately from what's being done in R&D? Do you see that as kind of the projection? I would just love to hear your reflection on that.
Yeah, I mean, it's definitely the kind of most productizable AI technology or technology that has come out of AI research. Right? This whole large language model concept, which there's a million of them. It's not just Chat, it's Grok, it's Llama, it's Gemini, and a bunch of other smaller ones. Because it's actually pretty simple to implement as long as you have enough computing power to train the thing. It's actually very simple. It uses probably advanced, 12th grade mathematics. Um, and so it's very productizable. And so I think that's what's happening is that they're going to productize and milk it as much as they possibly can. The bigger the company, I think they're going to milk it as much as they possibly can. And then obviously small companies and small organizations are going to jump on the bandwagon because they're so desperate to be part of the trend, so desperate to be so fearful of being eliminated in the disruption. Um, But no doubt we're going to continue to see more and more of this LLM based products. I think a lot of it will fizzle out. The stuff that's actually useful will win. We'll continue to get updates from OpenAI, such as their recent search integration, things like that. Small incremental improvements. Some data center will complete building in a year or two or something like that. Then 6 months, a year after that, some big model will come out that's crazy, and but fundamentally has the same flaws of what we've seen before, but it's just better at certain tasks, and we'll get a lot of iterative improvements over time with this particular technology. Is what I see.